Hello everyone, we continue building BudgetClick-2026, offline first, serverless, open source, multi-client, client encrypted, progressive web application for planning and tracking personal finance. And we continue following our roadmap. Last time we finished with the application shell. The GUI has been implemented, styles and layout components. And our current step is the initial setup flow. This is the flow when the user installs the application for the first time or runs the application for the first time. We need to provide the user guidance, onboard the user, initialize manifest if the storage is new. If the storage is new, if the user has never used this application and provides the storage is fresh, it's empty, so there's no manifest and the application cannot be initialized without the manifest. Next step we will cover today will be the local storage. We will use IndexedDB. It will consist of two sub-steps. The first step will be to set up IndexedDB, and the second step is to implement migration. We need to implement migration before we even touch any data, because as soon as we start working with the data, we will need to run migrations, because every next change in the database might require updating different places, for example remote storage and local storage. Now let's go step by step. Open our Git history. Okay, the first commit is settings client ID. We added client ID to the settings because this is how we identify the client. Every change of the data is signed with the client ID, so we need this client ID before we start working with the data. I also updated the initial values of the settings. Storage and client ID will be dash, not empty, because our settings UI does not allow empty strings. So if I try to save an empty string, I will get an error invalid settings. So I use dash. I made the same changes in the storage schema. Client ID is any string of any symbols, but not empty. Next step, I added help view. I added help to the menu and to the router. This is how it looks like. Help menu item here. I click it and this is the help. Let me read it aloud. Client ID. Your client ID identifies this application installation for synchronization and conflict detection. It is not a password and does not protect your financial data. Memorize or write down your client ID. If you reinstall BudgetClick, enter the same client ID in settings to restore this client identity. And we see this is reflected here. The client ID field has a hint, generate or use the existing client ID. This is used to identify your client instance if you reinstall the application. Go back to help view. Storage. BudgetClick stores your data in an S3 compatible storage bucket that you configure yourself. BudgetClick does not own or manage your storage. 1. Create a bucket. Create a dedicated bucket for BudgetClick using an S3 compatible provider such as AWS S3. Do not use a bucket containing other personal or important data. BudgetClick storage path acts as an access compatibility, which means that it's only you who knows this path for storage, and if someone else knows the path, then they can attack your storage. 2. Allow public access. BudgetClick does not use AWS credentials. The bucket therefore needs to allow anonymous read and write access to objects. If your provider has a public access blocking feature, configure it so that the bucket policy can grant public access. 3. Configure the bucket policy. The bucket policy should allow anonymous get object, put object, list bucket. It should not allow bucket deletion, bucket configuration changes, IAM access, or object deletion. For AWS S3, the policy is as follows. We grant BudgetClick public read-write, and we grant BudgetClick public list. Replace bucket name with the name of your bucket. This is the bucket name, which needs to be replaced with your actual bucket. 4. Enter the storage path. Copy the HTTPS URL of your bucket and enter it in the settings. For example, this one, and we go to the settings and we enter this path here. Go back. Offline use. BudgetClick is a progressive web app, PWA. Installing it allows the application to keep its application files available when the network is unavailable. Your local data is stored in the browser on the device. Then instructions how to install on desktop, how to install Android, how to install on iPhone or iPad. Important note, installing the PWA does not replace your storage. Remote data remains in your configured storage bucket while the application can continue working with locally cached data when offline. Keep your client ID, storage location, and encryption passphrase available. BudgetClick cannot recover them if they are lost. Encryption passphrase is mentioned here, but we have not yet implemented this. It will be implemented in one of the next steps. Next update is the model dialog. I added model dialog with the overlay. Model uses overlay. Overlay just covers all of the UI so that the user cannot interact with the UI and only with the model. We have only two buttons here, yes or no, and this is the model. This was installed because we need it in the UI, and this is a shared and reused component which we'll use throughout the application. The next commit is actually the main work done on initializing the application. It starts in the app view. I introduced isFirstLaunch variable, and it is computed as boolean when storage and client ID are not set and are initial values. And then if it is the first launch, then we show the setup flow, this setup components. Otherwise, we use just normal router view. What is this setup view? This is this new component, setup view, and this is exactly what we see here. Our application is not yet initialized, the values are uninitialized, so we go to the home view and we see this message: welcome to BudgetClick. Your application is not configured yet. Please configure your storage and client ID to get started. You can optionally install BudgetClick as PWA to use it offline, and then the user can read help or the main button configure settings. The settings were updated accordingly to the changes. Now we have two fields instead of one. There used to be only one field for the storage, and now we have the field for the storage, and now we have the field for the client ID. We also have the hints here, memorize or write down this client ID, and we also have this button to generate the client ID or use the existing client ID. We can generate the client ID, and generator is a simple mnemonic generator which combines several words. Let's try it. Okay. Wolf, light, bright, -60. And the hint says here, memorize or write down this client ID. You can enter it again after reinstalling the application to restore the client identity. Let's have a peek into this client ID generator. You see the number of words here, and the generate client ID simply takes random words from this list and combines them together, 1, 2, 3, and plus some random number within 100. The next improvement is the loading state. I added the loading state to the application so that the application can show the loading state and block the user from interacting with the application while the loading is in progress. And this is done using the set of loading IDs. We can have several processes running in parallel, so we need some way to show the loading overlay while at least one loading process is in progress. As I said, we introduced the new set which contains loading IDs. Is loading is true, it is exported state, and it is true as soon as the size of the set is more than 0, greater than 0. We have two exported functions here. One function is set loading on. It doesn't accept any arguments. It generates a loading ID it adds this loading ID to the set and it returns the loading ID so that we can use this generated loading ID to set loading off. And this is the second exported function, set loading off, which accepts loading ID as the argument, and it deletes this ID from the set. So this is how it works. I also added the spinner and spinner overlay. This is the icon with animation, and spinner overlay is overlay with this spinner icon. Let me show how it works. I will set the loading state to always true, and this is how it looks like. So you see that the application is blocked, the user cannot operate the main UI, and all the user sees is only the loading spinner. And this is all for the provide user guidance. The next step is to initialize the manifest if the storage is new. So the point is that if the storage is new, then we need to create and save manifest. In this commit, we update how settings are initialized. First of all, we show the model, which suggests that we initialize the storage because it's new, and we also add the error model, which showed us that the storage could not be initialized if there is a problem with the storage. And you can see we make use of this new loading workflow, and we change the save function. It used to be just update settings and save settings, and now we also initialize manifest. Initialize manifest checks if manifest exists in the storage and suggests the user to create the manifest. Then the user can initialize the new storage. If the user says, yes, I want to initialize the storage, and the initializing of the new storage is attempting. So we set this loading on again, and we run initialize new manifest. Now let's have a peek what those two functions do. So we have this manifest service file here, and we have those new functions. Create manifest, it just returns this object. Then initialize manifest attempts to get file from this storage. And then we have new function, initialize new manifest, which tries to create manifest. And this is exactly this function, create manifest, which returns us the new contents of the manifest, the fresh contents of the manifest. And here on the left you see that test update was removed. It was a temporary function which we used to test the storage. And the last step in this initial setup flow part is adding tests. So we added app tests, application shell initialization, shows setup when manifest is not initialized, does not show setup when manifest is initialized. Then I added public data test. This is the test of the public data, which is config, settings, and manifest. Here we test that the files saved here in public directory config and settings are valid because they will be used during the initialization of the application. And the other thing which is used during the application initialization is this create manifest function, which creates a new manifest, and we also try to validate it. Setting tests. This test tests the UI. The test is called settings storage initialization. It shows the initialization dialog when the manifest is missing. It initializes a new manifest when confirmed, closes the initialization dialog when declined, shows an error when new manifest initialization fails, and saves settings before checking storage. And before going on further, let me show you how this process works on this UI. So this is the initial state. I define a storage, let's say storage. This is an existing directory which already initialized with manifest, and I defined local dev as client ID. Now I click save, and now we see this hint that storage is initialized. If I go back home, that you see that dashboard, the normal dashboard is shown and not the setup flow. Now let me change storage path to something invalid. So let's say storages. This directory is not initialized with manifest, and it should throw an error now. I'm clicking save, and now you see that the application says, hey, this storage is not initialized, I cannot get any manifest from this storage. Should I create new manifest in this directory? Maybe this is a new directory, and this directory is the storage of the data. This is how we connect the application to the data. Without the storage, there's no data. So I click yes, and now it attempts to, you see this progress of network requests here. It tries to get and tries to post the manifest, gets the error, and now we see this error that storage could not be initialized. All I can do is just click OK, and now I change back to storage, save, okay, storage initialized, and I go back to BudgetClick home, and the normal dashboard is displayed. This step is complete, initial setup flow, and let's continue to the next step, local IndexedDB storage. IndexedDB storage is the local data storage. We use IndexedDB for that. First sub-step is to set up IndexedDB, and the second sub-step is to implement migration. We need to implement migration because we need this before we start to work with the data, because any change will need to be migrated and not just changed. Before switching to that step, I also made a small update to the local server. Now it returns the status 400 and not just 500. 400 is bad request and 500 is internal server error, which is not informative. So I made the application is a little bit more informative. Also, get can return 404, not found. Okay, let's continue to setting up IndexedDB. The first thing which was done is IndexedDB contract. Let me go through it. BudgetClick-2026 IndexedDB contract. Design principles. IndexedDB is the local working database for the offline first application. The local database mirrors the logical storage object structure used by remote storage. The database stores decrypted application data. Remote storage stores encrypted object. IndexedDB is not a relational database. Relationships between entities are represented by identifiers and resolved by application logic. Important. Database name BudgetClick, initial database version 1. The database version is controlled exclusively by IndexedDB schema migrations. So that's why we'll need migrations. Object stores. The initial database contains these object stores: manifest, identified by key, accounts, categories, contractors, and chunks identified by months. Each store represents a logical storage object or group of storage objects. Manifest. The manifest store contains the latest locally available manifest. The manifest is cached locally so the application can continue operating when remote storage is unavailable. The local manifest is not necessarily the current remote manifest. When online, the remote manifest remains the synchronization source of truth. The store contains one record, key manifest. The value is a manifest. Reference objects. The following stores contain the corresponding decrypted remote storage objects. Decrypted. Accounts as account storage, categories as category storage, contractors as contractor storage. Each store contains one record. The record key is key equals current. The metadata and entity arrays are stored together as defined by the corresponding storage type. Monthly chunks. The chunks store contains local copies of monthly transaction chunks. Each record corresponds to one remote chunk storage object. The record key is the month, year, month. For example, 2026-08. The record value is a chunk storage. Transactions remain inside their monthly chunk rather than being stored as individual IndexedDB records. This mirrors the remote storage model: remote storage, chunk object, chunk storage, transaction, and locally IndexedDB chunks, chunk storage, transaction. Keys. The manifest, accounts, categories, and contractors stores contain one current record each. The chunks store uses the month as its primary key. Remote object keys, such as object key, are stored in the manifest and are not used as IndexedDB primary keys. Indices. The initial schema does not define indices. Transactions are stored inside monthly chunks and are queried in application code. Additional indices may be introduced when concrete application requirements justify them. Offline operation. The application must be able to operate using the locally cached IndexedDB state when remote storage is unavailable. At minimum, offline operation requires locally cached manifest, locally cached reference objects, locally cached monthly chunks. User changes are applied to local data immediately. Synchronization with remote storage occurs separately when storage becomes available. The application must not require a successful remote manifest request merely to open and use existing local data. Synchronization state. IndexedDB must preserve enough local state for synchronization to resume after application restart, temporary network failure, remote storage failure. Dirty state and synchronization metadata are local concerns. They must not be added to the remote storage objects unless explicitly required by the storage contract. A dedicated metadata store is not part of the initial schema. It will be introduced only when a concrete local metadata requirement cannot be represented by the existing stores. Transactions. Changes affecting multiple local storage objects must use an IndexedDB transaction when atomicity is required. The database adapter must expose transaction boundaries without exposing IndexedDB implementation details to the main logic. Versioning. Database schema changes are represented by IndexedDB database version. Example, version 1, version 2, version 3. A newer database version may add or modify stores and indices. Existing migration versions are immutable. Migrations are applied sequentially. Initialization. Application startup must 1. Open the BudgetClick database. 2. Apply required schema upgrades. 3. Make the database available to application state. 4. Continue startup only after database initialization succeeds. The database must not consider initialized when opening or upgrading fails. Relationship to remote storage. IndexedDB is the local working copy. Remote S3 storage remains the shared source of truth. The relationship is remote encrypted object, download, decrypt, IndexedDB storage object, local changes, encrypt, upload, remote encrypted object. The local database therefore mirrors the logical storage object structure while containing decrypted data suitable for offline application use. MVP scope. The initial IndexedDB implementation includes manifest, accounts, categories, contractors, monthly transaction chunks. The following are not included: attachments, separate transaction core, store, generic metadata store, synchronization engine, migration engine. Okay, actually migration engine will be implemented right away, just in a couple of minutes. And these are implemented in subsequent development steps, which is again true. Okay, and now let's continue with setting up the IndexedDB. Let's check the roadmap. You see that this is updated here. Setting up IndexedDB is set as done. This is done with those two updates. Now this is indexed init.ts, and I added initialized database step to the initialization of the application. And this is how the database is initialized. We just try to connect to the database with the given name. Database name is BudgetClick, database versions here. And we also have this database handler here, or pointer, which is used to return the database using this exported function getDatabase. So when we initialize database, we try to connect to this database with this name and this version, and if it's a success, then we set this database pointer to the result of the request. Otherwise, we throw an error. This is the simple step of IndexedDB initialization. Now the next step is implementing migration. We add onUpgradeNeeded event and handler, and if this event happens or fired, then we use this migrate function from the migration migrate. You may also notice that we added the loading workflow here. When the database is connected or initialized, we show the loading state, and when the database has finished initialization, then we turn loading off. Migrate.ts is the main runner. It exports only one function, migrate, and the only thing it does is just runs the migrations and provides the console output. Migrations are here. This is just array of objects with the version and migration function. The migration functions are located in migrations, then the number of migration and the migration file, and the first migration is here. This is a simple migration which creates object store, accounts, categories, and contractors. This is how migration works. It's also very simple. There is no rollback, only forward migration, and the new application will initialize the database, and if the migration is needed, then all those migrations here will be run sequentially, one by one. And the final logical step in this flow is updating the roadmap. So we mark all those steps as done. And this will be all for this episode. Thank you very much for watching. And in the next episode, we will continue with the next steps. And the next steps will be setting up the data. It's not encryption layer. Actually, it will be setting up the data, because before implementing the encryption layer, we will need some data, maybe dummy data, on remote storage and local storage as well. Again, thank you very much for watching, and looking forward to seeing you in the next episode.